Alright, so we got a problem here. Raw egg is thrown horizontally straight out of the open window of a frat house. If its initial speed is 20 meters per second and it hits the ground 2 seconds later, at what height was it launched? At such low speeds, air friction is negligible. Alright, I'm going to add another thing. I want to know how far the egg actually went. You know, it doesn't, but I want to know how far it could have hit the sidewalk. Okay, we'll kind of add that in as a second part. So we'll draw a figure here first. All right.
I thought you meant the second part.
No. So listen, I drew a little figure. Got the frat house shown over here, right? And I have the egg right here getting thrown out horizontally at 20 meters per second. We know it's going to have a parabolic shape, dotted line, and it's going to crash right over here at the ground. And the time in the air is 2 seconds. And I got a guy here yelling toga, just so we make sure it's a frat house. All right. So the question is, at what height? So they want to know, the unknown here, does everybody agree, is this, which I'll call S in the Y direction. That's the unknown. So my known as time is 2, S of Y is question mark. My velocity initial in the X direction is 20 meters per second. What's my velocity initial in the Y?
0.
0. It got thrown horizontally. Is there any acceleration in the X direction? Not in the X. So I would say the acceleration of X is 0, and the acceleration in Y is what? It's gravity. And since we're doing this in meters, we're doing it in meters, so listen, we don't want to use 32.2, we want to use 9.81 meters per second squared. Now, I'm going to set my 0 right here at the window, and I'm going to call down positive. Everybody with me on this? So here's my 0, and down is positive. All right. We don't have to worry about the X direction. We only have to worry about the Y. An egg that is thrown from a window horizontally versus an egg that simply dropped will fall in the same time. So I'll do a Y direction calculation. All right. And since the initial velocity is 0, the formula I want to use, and it is this way so often in free fall, is this, because I know time. So this goes to 0 because the initial velocity is 0. S equals 1/2. The acceleration is gravity. The time is 2.0 seconds, 20 squared. All right. If I do the math, 4 times half is 2, 2 times 9.81. I get S equals 19.62 meters. So we start thinking about that. This is getting thrown roughly 20 times 3. It must be this guy's standing on the roof of the frat house, guys. It must be a 3-story frat house. He must be standing on the roof because he is tossing it from nearly 20 meters at 3 feet a meter, roughly. That's 60 feet in the air. So this is getting tossed from quite a height. We ignored air pressure. The real question I have then is how far out does it land? Who cares how high he is? The whole object of tossing the egg is to hit some poor person walking right here. Do we all agree? You know, the toga. All right, so if we're trying to hit that guy, think about it. We now know that time is 2. If I do this in the X direction, I can use the same formula. S equals VIT plus 1/2 AT squared. But in the X direction, do we all agree acceleration is 0? So this goes to 0. So the S distance is just a 20 meters per second times 2 seconds. Guess how far out it goes? 40 meters. This guy chucked an egg from 60 feet in the air, and he chucked it out 120 feet. This guy has to be Superman. You guys see this? So 40 meters, like that is a long ways. All right.
It's an egg.
A marshmallow.
You can throw an egg 40 meters.
It's marshmallow.
We'll have to have an experiment sometime. Anyway, Good problem. And again, separating x and y directions, guys. Do you see how we separated x and y directions? Always by components. You want to make that noise?